Hello my dear students, today I am going to discuss class 6th current electricity worksheet 3. Here I am not going to discuss worksheet 1 and 2 because it is completely based on concepts. That's why I am not going to discuss the worksheet 1 and 2. If you can follow my previous lectures and if you can read the synopsis from the textbook, it is very easy to solve the worksheets 1 and 2. That's why I am not going to discuss. Worksheet 3 is having some numericals and some difficult questions. I am going to discuss the difficult and numerical questions only. Okay, so let us not waste our time. I am going to start the lecture. See the first question. In case of with increase in temperature, the resistance of a conductor. See what happens. If we increase the temperature, resistance of a conductor also increases. Because if we increase the temperature, what happens? Length of the resistor increases. If the length of the resistor is increased, as you know that the resistance is directly proportional to the length. If length is increased, resistance also increases. Got it? I repeat, if we increase the temperature, length of the conductor or length of a resistor, this increases upon heating. As the length is increased, resistance also increases. So the right answer is B. In series combination, the total resistance. See, let us see what is series combination. If this is a resistor of resistance R1, another resistor of resistance R2 is connected like this. This is called as a series combination. In the series combination, as we have discussed earlier in the synopsis, the formula is R effective is equal to R1 plus R2. So, as we are directly adding them, the resistance obviously increases. If you want, I will take one example. If the resistance R1 is 1 ohm and resistance R2 is 2 ohms, what is the effective resistance? 1 plus 2, which is equal to 3. This 3 is greater than 1 and this 3 is greater than 2. Means what happened? The resistance increases. Yeah. Actually, all these we have discussed in our synopsis, but I repeat this again. In parallel combination, the total resistance, you can say. What is the effective resistance in the parallel combination? 1 by R is equal to 1 by R1 plus 1 by R2. Actually, what is our parallel combination? If this is resistance of our resistance R1, if this is a resistor of resistance R2, if they are connected like this to a battery, we call this as a parallel combination. In this parallel combination, this is the formula for effective resistance. I have given the proof of it in the earlier video. You can go through that. So, in this what happens? As you know that if we simplify this, 1 by R is equal to R1 R2. This is R2 plus R1. So, the R effective is nothing but R1 R2 by R1 plus R2. Actually, the resultant of resistance Rp will be definitely less than R1 and it will be definitely less than R2. So, if I say like this, you can't understand, but I will take some numerical values and I will explain you, then you can better understand. For example, if I take R1 is equal to some 1 ohm, R2 is equal to 2 ohms, let us see what is the effective resistance. 1 into 2 by 1 plus 2, which is equal to 2 by 3. So, which is nothing but 0.66. So, this 0.66 is obviously less than 1, means it is less than R1. It is also less than 2, means R2, means R parallel combination is less than R1 and it is less than R2, means the effective resistance will be less than the least in the parallel combination. And for example, manam different resistors తీసుకున్నాం అనుకుందాం 1 ohm, 2 ohms, 3 ohms, 4 ohms, 5 ohms like this. తీసుకుంటే వీటన్నిటికి ఎఫెక్టివ్ రెసిస్టెన్స్ అనేది ఎవరికంటే తక్కువ ఉంటుంది? లీస్ట్ కంటే కూడా తక్కువ ఉంటుంది. అంటే ద ఎఫెక్టివ్ రెసిస్టెన్స్ ఇన్ దిస్ కాంబినేషన్ ఇస్ లెస్ దెన్ 1. అంటే దీనికంటే కూడా తక్కువ ఉందంటే మిగిలిన వాటి కంటే ఆటోమేటిక్గా తక్కువగానే ఉంటుంది. సో దీస్ అబౌట్ అవర్ ప్యారలల్ కాంబినేషన్. సో ఇన్ ప్యారలల్ కాంబినేషన్ ద ఎఫెక్టివ్ రెసిస్టెన్స్ decreases is our answer. In series combination, resistance increases due to increase in, as we have discussed in the previous problem. In series combination, the effective resistance increases. Why? In series combination, what happens? This is resistor 1, this is resistor 2, this is resistor 3, like this. What happens? If this is length L1, if its length is L2, if its length is L3, what is the final length? L1 plus L2 plus L3. So, in the series combination, the length is increasing. As the length is increasing, the resistance increases. As we have already studied that R is directly proportional to L. So, if length is increased, resistance increases. So, here what is the effective length? L1 plus L2 plus L3. The length is increased, hence resistance is increased. In parallel combination, resistance decreases due to increase in. So, a parallel combination means this resistor R1, this is one more resistor R2, this is one more resistor R3, like this. So means resistors are collected and made them as a bunch like this. 1, 2, 3, 4 like this. If they made as a bunch, what happens? Can you say that length is increased? Need not. But area of cross section increases. So this is one resistor, single resistor. This is second one, this is third one, this is fourth one, this is fifth one, like this. Means what happens? Here the area of cross section increases, hence the resistance decreases. As you know that R is inversely proportional to A. So if area of cross section is increased, resistance decreases. So in parallel combination, the resistance decreases. This is decreased because of the increment of area. So this is simple question. When electric current flows through a conductor, what happens? It becomes hot. So actually what happens, if this is a conductor, when the electrons are moving, they move in zigzag motions. During the motion, what happens? They collide with each other. Hence, during each collision, they lost some kinetic energy and it releases in the form of heat. That's why the wire gets heated. When electric current flows through a conductor, what happens? Free electrons move. Of course, atoms move? No. Atoms will never move. Atoms attract free electrons? No. Atoms repulse free electrons? No. Only free electrons move. Actually, the current is due to the motion of free electrons, right? So, the electrons are moving means that is called as a current. Current means a flow, okay? But in conventional, we say that the direction of current is not the direction of motion of electrons. It is the direction opposite to the direction of motion of the electrons. That is different story. In other case, I will explain. But remember, direction of current is not in the direction of electrons motion. It is in the direction opposite to the direction of motion of the electron. Simply, we can say that the direction in which a positive charge can move. Actually, positive charges will never move. But if a positive charge moves, then the direction of the positive charge gives the direction of the electric current. So here the answer is motion of free electrons. This is the straight away questions. Some straight questions I will skip because these are available in the notes and synopsis in the textbook also. Only difficult questions I will explain, but I will put a tick mark. You can check why. The unit of specific resistance is ohmmeter. The reciprocal of resistance is conductance. If the unit of resistance is ohm, the unit of conductance will be. This is also available in the notes and synopsis video and also in textbook. Direct question. If it is ohm, as we are reversing this, it is mho, MHO. The S unit of specific resistance is ohmmeter. The effective resistance of a circuit containing resistance in parallel is, just now I have explained in the previous problem, smaller than any of the individual resistances. B. Which of the following have highest conductivity? Of course, insulators will not have any conductivity, semiconductors are having less. So, copper. Copper is a good conductor and copper is having highest conductivity among the following. In domestic electric circuits, the cheapest appliance used is fan, television, bulb. When compared to these three, fuse is the cheapest. I hope you know fuse. Whenever there is short circuit in the current in our households, fuse, the fuse wire melts and the current breaks down and all the appliances will be safe. So there is fuse. Okay, I'll explain this problem. In an voltmeter, there are 20 divisions between 0 and 0.5 mark. So say this is voltmeter, this is 0 and say this is 0.5 mark. There are 20 divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is first point and this is 20th point. The least count of the voltmeter is, so with the needle of the voltmeter, what you can do? You can measure from here to here. That is the least here and here. So this is the least point that you can measure with by using the voltmeter. This is the least measurement. So if 0.5 is divided into 20 parts, what is the each division? 0.5 by 20. So if you simplify, whatever, that is the answer. If you divide this with 20, you will get this answer. You can calculate this. A man has 5 resistors. Each value is 1 by 5 ohms. What is the maximum resistance he can obtain by combining them? So he has 5 resistances. 1, 2, 3, 4, 5. So to get the maximum resistance, what is the best combination? We have only 2 combinations, series and parallel. By mixing series and parallel, you can make different combinations also, of course. But in the series and parallel combination, which combination gives you the maximum resistance? Yes, combining in series. Series combination gives you the maximum resistance and parallel combination gives you the minimum resistance. So, as he is asking, what is the maximum? We have to add them in series. 1, 2, 3, 4, 5 like this. So, what is the effective resistance when they are connected in series? R is equal to R1 plus R2 plus R3 plus R4 plus R5. If all are equal, what is this? R plus 5 times, which is nothing but 5R. This is the 5R, which is nothing but the R effective, R series. So R series is equal to 5 times of 1 by 5, which is equal to 1 ohm. So this is the maximum possible resistance. If they ask you what is the minimum possible resistance, then you should connect them in parallel. In parallel combination, the formula is 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And if you substitute and simplify accordingly, you will get the answer. That will be R by 5. Means 1 by 5 divided by 5, which is equal to 1 by 25. Of course, that question is not asked here. I am explaining just for your better information. This is very interesting question. You have to concentrate more. If the length of wire is doubled and its cross section also doubled, then the resistance will be, as we know that R is equal to rho L by A. If the length of wire is doubled and its area of cross section also doubled, then the resistance will be his asking. Length is doubled, area of cross section also doubled, then what is the resistance? Means R1 by R2 means what you have to write, as rho is the same, we can ignore this rho, L1 by L2 into A2 by A1. Being mathematics student, you can understand this. L1 is equal to say L, L2 is equal to say 2L. As the length is doubled, it is 2L. A1 is equal to A, A2 equal to how much? 2A. So if you substitute them here, L1 means L by L2 means 2L into A2 means how much? 2A. A1 means how much? A gets cancelled, L gets cancelled, 2 gets cancelled, which is nothing but 1. Means R1 equal to how much? R2 means there is no change, remains unchanged. This is a very important and a somewhat difficult problem. You have to consider more. If a wire of resistance 1 ohm is stretched to double its length, then the resistance will be, I will tell you this problem in 2 methods. First method everybody will do and get wrong answer. I will tell that first. And the second method is the correct method. Only genius people like you can do it. I will tell you that later. So what a common man do? What happened here? If wire of resistance 1 ohm is stretched to double its length, then the resistance will be, here he didn't speak anything about area. He spoke only about the length. As you know that R is equal to rho L by A, as he didn't speak about area and specific resistance is same for the particular material, we can say that R is proportional to L. Means we can say that R1 by R2 is equal to L1 by L2. Say for example, if the R1 is R1 is equal to R, R2 means R2, L1 means say that is L, L2, what is L2? Stretch it to double its length, means the final length is double the initial length, means 2L. LL gets cancelled, then R2 is equal to how much? If you cross multiply, 2R. R is nothing but 1 ohm, so you can say that 2 into 1, which is equal to 2 ohms. So you got the answer as 2 ohms. Option B, you may say that it is correct. As I said that maximum people will do this in wrong method. So here 2 is wrong. This is wrong method. You may say that, sir, length is doubled, I have kept 12. What's wrong? But actually the problem is, he didn't make the length into double. Means he didn't add any another wire. If wire is there, if another wire is attached to double its length, then your answer is correct. అర్థమవుతుందా? అంటే ఒక వైర్ తీసుకున్నాడు, ఇంకో వైర్ని కలిపాడు. ఇంకొక వైర్ని కలిపి లెంత్ డబుల్ చేశాడు అనుకోండి, అప్పుడు ఈ ప్రాబ్లం కరెక్టే. కానీ ఇక్కడ వాడు ఇంకొక వైర్ని కలిపానని చెప్పలేదు, ఏం చెప్పాడు? స్ట్రెచ్డ్ అని చెప్పాడండి. హీ స్ట్రెచ్డ్ టు డబుల్ ఇట్స్ లెంత్, అంటే అదే వైర్ని దాని ఒక లెంత్ ని డబల్ చేసే విధంగా స్ట్రెచ్ చేశాడు అనమాట. అలా స్ట్రెచ్ చేయడం వల్ల రెసిస్టెన్స్ ఎలా మారింది అని అడుగుతున్నాడు. కాబట్టి ఇప్పుడు మెథడ్ 2 అనేది కరెక్ట్ మెథడ్. ఆ మెథడ్ చెప్తాను, జస్ట్ ఫాలో మీ. నౌ అబ్జర్వ్ దిస్ ప్రాబ్లం. యాక్చువల్లీ దిస్ ఈజ్ అవర్ వైర్ ఆఫ్ లెంత్ L. మీరు ఎప్పుడైనా గమనించారా? మీరు చూయింగ్ గమ్ తింటారు కదా, చూయింగ్ గమ్ తినేటప్పుడు ఒకసారి ఇలా దాన్ని స్ట్రెచ్ చేయండి, ఏమవుతుంది? లెంత్ పెరుగుతుంది కదా. మరి బ్రెడ్త్ ఏమవుతుందండి? తగ్గుతుందా లేదా? సో లెంత్ ఇంక్రీజెస్, బ్రెడ్త్ డిక్రీజెస్, ఆర్ రేడియస్ డిక్రీజెస్, ఆర్ విడ్త్ డిక్రీజెస్. అంటే ఇప్పుడు దీన్ని లెంత్ నేను ఎప్పుడైతే డబల్ చేశానో విడ్త్ ఏమవుతుంది? తగ్గుతుంది. మీన్స్ సి సన్నం అయిపోయింది. సన్నం ఏంటంటే అర్థం ఏంటి? ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఈజ్ డిక్రీజ్డ్, లెంత్ ఇంక్రీజ్డ్, ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఈజ్ డిక్రీజ్డ్. మనం ఇంతకుముందు మెథడ్ 1లో చేసినప్పుడు చూడండి, ఏరియా ఆఫ్ క్రాస్ సెక్షన్ గురించి మాట్లాడలేదు మనం, కానీ ఏరియా ఆఫ్ క్రాస్ సెక్షన్ అనేది ఇంపాక్ట్ అయ్యింది. అందుకే ఈ ప్రాబ్లము కొంచెం జాగ్రత్తగా మీరు వినాలి. సో ఇక్కడ లెంత్ ఎప్పుడైతే ఇంక్రీజ్ అయింది, ఏరియా ఆఫ్ క్రాస్ సెక్షన్ అనేది డిక్రీజ్ అయింది. దట్స్ వై వీ హ్యావ్ టు స్పీక్ అండ్ థింక్ అబౌట్ ది ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఆల్సో. So now our formula is R is equal to rho L by A. Here length is affected and area of cross section also affected. But as the material is not changed, this rho is not affected. మరి ఎలా చేస్తాం సార్? లెంత్ అయితే డబుల్ అయిందని చెప్పాడు, కానీ ఏరియా ఆఫ్ క్రాస్ సెక్షన్ డబుల్ అయిందా, హాఫ్ అయిందా, లేదా 1/4 అయిందా చెప్పలేదు కదా. మరి ఎట్లా చేస్తాం? దట్స్ వై వీ హ్యావ్ టు ఫాలో వన్ ట్రిక్. అఫ్ కోర్స్ దీన్ని నేను సినాప్సిస్ లో కూడా చెప్పాను, కానీ కొందరు సినాప్సిస్ లో మిస్ అయి ఉన్న వాళ్ళ కోసం అని చెప్పి మళ్ళీ ఇక్కడ చెప్తున్నాను. సో ఇక్కడ ఏరియా ఆఫ్ క్రాస్ సెక్షన్ గురించి ఏం చెప్పలేదు, కాబట్టి మనం ఏం చేయాలి అంటే మనకి లెంత్ గురించి మాత్రమే చెప్పాడు కదా, కాబట్టి లెంత్నే హైలైట్ చేద్దాం. ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఎలాగైనా సరే ఇక్కడ నుంచి బయటికి ఎగిరిపోయేటట్టు చేద్దాం. చేయాలంటే ఏం చేద్దాం? నేను ఒక ఎగ్జాంపుల్ చెప్తా చూడండి. ఒక గ్లాస్ జార్ని తీసుకున్నాను, ఇందులో 1 లీటర్ వాటర్ వేసానండి. ఓకే, ఇప్పుడు నేను ఒక పెద్ద వాటర్ బాటిల్ తీసుకొని ఇదే వాటర్ని ఇందులో వేసేసాను. అర్థమైంది? ఇప్పుడు ఏం జరిగింది? ఏరియా ఆఫ్ క్రాస్ సెక్షన్ డిక్రీజ్డ్, లెంత్ ఇంక్రీజ్డ్. చూడండి, ఒకప్పుడు ఇంత లెంత్ ఉండేది కదా, ఇప్పుడు లెంత్ ఇంక్రీజ్ అయింది, ఏరియా ఆఫ్ క్రాస్ సెక్షన్ డిక్రీజ్ అయింది. బట్ ఇక్కడున్న వాటర్ యొక్క వాల్యూమ్ ఎంత? 1 లీటర్. ఇందులోకి వచ్చినప్పుడు వాల్యూమ్ ఎంత? 1 లీటర్. మీన్స్ వాల్యూమ్ రిమైన్స్ కాన్స్టెంట్. సో ఈ విషయాన్ని మనం గుర్తుపెట్టుకోవాలి. వాల్యూమ్ రిమైన్స్ constant. We have to take this principle only. Here the volume of the wire is not changed, length is increased, area of cross section is decreased. So ఈ ఫార్ములా నేను వాల్యూమ్ వచ్చే విధంగా మార్చాలి అంటే ఏం చేయాలి? కాబట్టి ఇప్పుడు ఫార్ములా ఒకసారి చూద్దాం. R is equal to ρl by A. ఇక్కడ ఏరియా అనేది మనకి వెళ్ళిపోవాలి బయటికి, కాబట్టి ఏరియాని బయటకు పంపించే విధంగా ఇంటూ L by L చేద్దామా? చేస్తే ఏమవుతుంది? It becomes R is equal to rho into L square, L into L square by A into L is nothing but volume. V. As we know that rho is constant now, volume is constant, then what happens? R is directly proportional to L square. Now we can apply the formula R1 by R2 is equal to L1 by L2 square. So R1 is nothing but how much? 1 ohm. R2 is equal to, we have to find. So 1 by R is equal to, L1 means to say L, L2 means to say 2L, double. It can be written a whole square. So LL gets cancelled. 1 over 2 whole square means 1 by 4. That implies R2 is equal to how much? 4 ohms. Upon cross multiplication, you can say that R is equal to 4. So the answer is 4 ohms. D is the right option, not B. I hope it is clear to you.